Okay, this is tutorial 11 in the present playlist, and it will be using the results of tutorials 9 and 10. I want to generate the helix as it was done in tutorial 8, except that I don't want to use the mathematical expressions for the coordinates of the helix point. Instead, I will be using laws, okay, not this law, because this means that you're going to be typing actually the formulas for x, y, and z, but that's not what I'm going to be doing. Here's the helix that you want to do, and instead of using these formulas, which was done in 8, we're going to generate 3 curves that were done in 9. The cosine curve, 3 cycles of cosine curve was generated, 10 3 cycles of sine curve was generated, and of course there I also created a line, so that's really doesn't matter. But these things, keep in mind that these things that we generated earlier, they had a height of 1, okay, and I have to adjust for that. I'll take that into account when it comes to creating the loss, specifying the appropriate uh, uh, scaling factor. Now, these are this is the icon that I'm going to be using, and that's the result in the dialog box in 3D experience. The counterpart of it is in Catia v5. It's exactly the same thing. Let me remind you that in tutorial 9, I took 11 points of the cosine curve, and then passed the spline through these and got 3 cycles. And the scaling that I was talking about is here, because this goes to the height of 1, but I want these things to go to the amplitude of 2, so I need to put a 2 in there, and we're going to take care of that in a minute. Okay, so let's go here. Everything is already done for you. So now we go to the transform. See that the transforms icon toolbar? We are in generative shape design. We go to transform toolbar, and this is what we want. Now keep in mind that if you wanted to type things, formulas as mathematical expression, you will go to tools. Make sure you expand this. Some of the stuff is hiding here. See this black triangle? You click on it, and there we are. This is not what we want. This was done in tutorial 8. So we go to transforms, you click on that. Let's start with the first one. So that is the cosine, 3 cycles of cosine. It says the reference. For the reference, I can select, see that the yellow axis right there? I can use the yellow axis here. And for the reference, I can use this entire thing, which is actually the join. You see that? Join. And the scalar factor should be 2, or the scaling factor should be 2. Okay, so there's my first law. For the second law, I can, for the reference, I'm going to be using, that yellow line is not shown here, it's hiding. But that, if that is the case, well, let me see. There's several ways you can do that. You can put a right click here and use the z-axis, for example, not the z-axis. What is this axis that's going this way? I think that is the y-axis. You can use that. Or if you want to get this thing back, let's go ahead and let's go to sketch, double sketch 2, correct? That was a sketch 2. It's probably hiding there, absolute axis. Well, I think we can take it from here if needed. Yeah, fine. So we go click on this. The reference is going to be that horizontal direction. You see that right there? And for the definition, we can either use join 2 or that entire thing. It really doesn't matter. And the scaling should be 2. Good. And the third one is that straight line. See that? Just here. Reference is going to be that, again, horizontal axis. Let me see, what did I pick? H direction, yeah, that's it. And for reference to that curve. And the scaling should be 6, because the horizontal distance was actually 1, and we want this thing to go 6 units up, 6 inches up. and you say okay. Good. So now we come to the final step where we actually have to generate the helix. So you go to wireframe. This is what we did in tutorial 8. You click on this curve from equation. For the first equation, use law number 1. For the y, use law number 2. And for the z, you use law number 3. I better get a helix. And I do, right there. And the distance from here to here should be 6. Let's check it out. Where's the distance here? From this point to that point, that's the height of the helix, should be 6. And it is. You can see that. And the radius better be 2. To confirm that the radius is 2, the easiest way of doing it, you go on that horizontal plane, you sketch a circle of radius 2, and it better matches that view from the top of the helix. 2. If I say 2 and hit return, these things match. In other words, if I exit, you can see that it's right there. This helix has radius 2. So this takes care of tutorial number 11. We did a lot of work, but the reason I did this is I wanted to show you that you don't have to have mathematical expression. I mean, if you have it, you can type it in with law with an f of x or fx, or you can have curves in space, sketches in space, which can be used as kind of your law. In other words, the height will be the height of these curves from the reference that you select, which incidentally does not even have to be a straight line, but it is, of course, in our case, straight line be the rule, the height, the law. Okay, good luck. I'm sorry, but I want to show you some of the things that are not easy to decipher when you go to the manual. So it's better if I did it through an example as I did in these tutorials. That's the whole purpose of creating these playlists for people who are already familiar with Catia V5. These is exactly the same way. This is exactly done the exactly the same way. It can be done exactly the same way as in Catia V5. But anyway, we are doing 3D experience. Good luck.